So this event tonight is part of our Forkenbrock series on public policy. And it's been part of this series on renewable energy that has really gone extremely well from our perspective. Most recently, last night, we had a debate from a person by the name of Mark Jacobson, who was here from Stanford, who was promoting you might say, a quicker route to getting renewables in the United States, and a person from the Manhattan Institute by the name of Robert Bryce, who was a little bit more cautious in our ability to get there. We involved a couple of members from the university debate team, and it was an outstanding discussion. And then today we had a symposium going on all day covering 4 broad areas around the question of renewables. The first one was general renewable energy policy, everything from energy security kinds of issues to economic issues. A second panel on biofuels, the next one on infrastructure, and then the fourth one on what's called distributed energy. And the whole idea is, can you put solar panels up on different places around, and how would you tie that into the grid, and what's the implications for the utility companies? The best thing about all of this, and the thing that we like best at the Public Policy Center, is being able to engage in these types of lively civil discourses in a civil way, and doing it around an evidence-based and around facts. And those were all researchers at the center, and that's what we like to do, is try to do the background research to inform policymakers. And so it really was a great event, and I think one of the things that I really enjoyed seeing is that the speakers that were here from all around the country really enjoyed being a part of it as much as anything else. You know, many of them go around and doing a lot of these things, and it's all one more of these. But you could tell afterwards that they really had fun sitting next to this person who they don't normally get a chance to sit next to, because that person might have completely opposite views about something, and yet be able to have that kind of banter that we think is really a good thing to do. So tonight we're collaborating with the University Lecture Committee on this public lecture. I would like to acknowledge, though, our co-sponsors for the whole series of events that included Iowa State University and Iowa EPSCoR, the University of Northern Iowa and the Center for Energy and Environmental Education, the Iowa Energy Center, and our on-campus colleagues, including, as I mentioned, the Lecture Committee, the Center for Global and Regional Environmental Research, the School of Urban and Regional Planning, and the Obermann Center for Advanced Studies, and the Digital Studio for the Public Arts and Humanities. And that's, this interdisciplinary nature to really be able to address the challenges with any of the huge issues that we're facing as a society are really important. So with that, I'd like to introduce Carter Bell, and she's a representative of the Lecture Committee who will introduce our speaker tonight.
Good evening. My name is Carter Bell, and I'm a member of the University Lecture Committee. The University Lecture Committee and the Public Policy Center are proud to co-sponsor the Meeting the Renewable Energy Challenge series. Thank you to the Public Policy Center for thinking of including University Lecture Committee on this wonderful event. Thank you to all of you for attending the final event in tonight's series, which is the public address with Dr. James Hansen. Dr. Hansen will have a Q&A after the event. Please just raise your hand if you have a question, and someone with a microphone will come around to you. I'd like to take a moment to mention University Lecture Committee's other large event for the fall. On October 29th, we will be partnering with the University of Iowa Dance Marathon to host a lecture by Alex Sheen, who's the founder of Because I Said I Would, a social movement dedicated to bettering humanity through promises made and kept. This will be held in the Dean Ballroom of the Sheraton Hotel. Doors will open at 7:15, and the lecture will begin at 7:30 with a free cookie reception to everyone attending after the lecture. And now I'd like to introduce tonight's renowned speaker. A graduate of the Space Science program under Dr. James Van Allen at the University of Iowa, Dr. James Hansen is currently an adjunct professor at Columbia University, where he directs a program called In Climate Science, Awareness, and Solutions. Dr. Hansen is a former director of the NASA Goddard Institute and received his bachelor in physics and mathematics, his master's degree in astronomy, and his PhD in physics, all from the University of Iowa. Dr. Hansen is well known for his research on the human impact on global climate and for his testimony to Congress in the 1980s that helped to greatly increase public awareness of global warming. A member of the U.S. National Academy of Sciences and a winner of the Sophie and Blue Planet Prizes, Dr. Hansen is an advocate for actions needed to protect the future of young people and all species on this planet. Please join me in welcoming Dr. James Hansen.
Hi, thanks very much. In my old age, I recognize how fortunate I was to come to the University of Iowa and get educated here and learn the objectivity and the honesty of the scientific method. And there was no better example in the world than Professor James Van Allen. And I'm glad to see that there are a few young people in the audience. One of our problems, one of the difficulties that we have in this issue is that the people who have the most at stake are young people, and yet they don't seem to fully realize that, and we really need them to help put pressure on the political system. Otherwise, there's a danger that things won't work out as well as they should. I started out very reasonable in my life, I think. My family was involved in socially useful activity. I was the fifth child, the first son of a itinerant tenant farmer. We would go from one farm to another, sharing the crops with the owner of the farm. And in this photo, my four older sisters are in there. The three of them look like they're abusing that cow, but actually they're so that milk cow, but they're so skinny I don't think she minds at all. But somehow from that good early beginning, I've ended up on the wrong side of the law, and although I've kind of lost count, but I think at least 5 times. I'm at least a 5-time loser, and the police seem to be getting burlier as. But I was really lucky to, at Iowa is very generous in keeping the cost of education within the reach of everybody. At least that was true decades ago. I hope it's still true. Even though the graduates often go off to West Coast or East Coast where more jobs might be located, but I was in high school at the time of Sputnik, and I came to the University of Iowa and started in mathematics, but took physics as a sophomore and got attracted to this remarkable program, the excitement in Professor Van Allen's program. He was building instruments in the basement of the physics building, and he had an instrument on the very first United States satellite with which he discovered the radiation belts around the Earth. And I was much too shy and unconfident. I actually avoided specifically taking any courses under Professor Van Allen. And that's a very bad strategy for students. You're much better off if sitting in the front row than the back row and trying to engage with professors. But by good luck, my astronomy professor, when I was a senior, he recognized I was a good student, so he suggested that I take the PhD qualifying exams as an undergraduate. And I happened to pass them and also get quite a high score. So Van Allen noticed me. It was just by luck. And then, so he then told me about interesting data that had come out on microwave radiation from Venus. And he wanted to know, was that because Venus had an ionosphere, or was Venus extremely hot? And it was thermal radiation. So that led me to investigate that issue and write my PhD thesis on that issue. And then I went off to NASA, where I proposed an experiment to go to Venus to study these mysterious clouds around the planet Venus. It took 5 years to build the instrument. And by the way, what we learned about Venus was that it was thermal radiation. It was very hot. And the reason it was very hot is because it has a lot of carbon dioxide in the atmosphere. So when this instrument was being built, I got involved in trying to calculate what the effect of increasing methane and nitrous oxide, which had recently been realized they were increasing, as well as carbon dioxide. And it was obvious that Earth is a much more interesting planet and more important because it has people living on it. And we would like to know what the impact of these increasing gases would be. So I resigned as the principal investigator on the Venus experiment. That image of Venus, by the way, was taken by our little 1.5-inch telescope on the Pioneer Venus mission. But I began to work full-time on trying to model the Earth's atmosphere and climate so we could understand the effect of the increasing greenhouse gases. And within 5 years, we had some results which we published in an article in Science magazine in 1981. Among other things, we pointed out that contrary to the then common belief that the Earth was cooling off, we found that in recent years it had actually warmed up such that the total temperature change over the century was about plus 0.4 degrees Celsius. And that was in good agreement with what we calculated from our climate model. And we made the prediction that the warming would rise to a level above the natural variability by the 1990s, and that in the 20th century we would see the increasing areas of drought-prone regions in North America and Asia, opening of the fabled Northwest Passage, and melting of Greenland and Antarctic ice sheets beginning to occur and raise sea level, things which have in fact begun to happen. Because of that testimony, and that was reported on the front page of the New York Times by Walter Sullivan, a science writer, and that led to requests to testify to Congress during the 1980s. Finally, in 1988, it was possible to get attention because it was a very hot summer. There was a drought that dried up the Mississippi River, and we had a paper that had been accepted for publication in JGR, the Journal of Geophysical Research, in which we showed that the climate change over the period from 1950 to the late 1980s was, again, consistent with what we expect for the changing atmospheric composition. And I made a fairly strong statement that it was time to stop waffling so much and say that the human-made greenhouse effect was happening and beginning to affect the climate. But then I realized within a day or so that this may be misunderstood, and people think, well, then every year is going to be warm. But the warming at that time, and even today, is still smaller than natural variability on short time scales. So I made up these colored dice to say what is happening is we're changing the odds, the frequency of warm seasons. And I also decided that I didn't particularly like the public aspect of this story, so I decided I would, and Michael Oppenheimer, who was with me on this Sunday news program, said he would be happy to deal with the media, and also my friend Steve Schneider. However, I did want I did want to testify once more because the other confusion that I was afraid I was introducing because I was doing this testimony during an extreme drought is the perception that, oh, we should always expect more drought. Well, higher temperatures do cause faster evaporation and therefore stronger droughts. But it also increases the total evaporation, and that what goes up comes down. The only problem is it comes down in more extreme events. And so you're going to get more extreme rainfall events and heavier floods. So the 100-year flood will occur more often. So I wanted to make clear that both ends of the hydrologic cycle get pumped up as we make the planet hotter. And so I wanted to testify once more in 1989. Unfortunately, as continues to occur, when my testimony went first to the White House, and they made some changes in it. And so it annoyed me because I don't think that's the way science works. And so I sent a note to the chairman of the Senate committee and said, please ask me about these specific sentences because these were not written by me. And he told the New York Times, and then that led to some cartoons like this one. In fact, there was one in the Des Moines Register, which was a little more direct. Then that is when I decided, I was able to keep my job, even though John Sununu wanted to have me fired, because a Republican senator came to my rescue. It was John Hines of Pennsylvania. But I decided I preferred to do science. So for the next 15 years after that, I avoided the media, and I would send them to Steve Schneider and Michael Oppenheimer. And it took me a long time to really figure out this thing. Even this was my first grandchild, and I still didn't get it then. I showed this photo of Sophie at a talk I was giving at Lamont Observatory because the day before there was a newspaper article that called me the grandfather of global warming. And I wanted to show that I was a grandfather, even though I was not the grandfather of global warming. There are scientists way before me that understood the greenhouse effect. And then in the first term of the Bush administration, I had the opportunity to speak to the President's Climate and Energy Task Force, which was chaired by Vice President Cheney and had 6 cabinet members on it. And I got to speak with them twice. And of course, I had no impact. Along with me, they had Dick Lindzen, and so they could say, well, there's this opinion and there's that opinion. And they still had plans to build 100 coal-fired power plants. And so then I decided I did want to try to make this story clear by giving a public talk. And there was an organization that was going to sponsor this talk in Washington and arrange for publicity, and I wanted to make clear, and you know, it was 2004, it was election year, and I was going to say, I think we need a different administration. But what happened was the sponsoring organization decided Bush might win the election again, and so they chickened out. And I had to call Professor Van Allen, and he arranged for a so-called distinguished lecture here in Iowa City. So I got to give my talk anyway, even though it wasn't at the National Press Club. But the point that had become clear was that we can't burn all the fossil fuels. We've burned only a small fraction of all the fossil fuels, the purple parts of the conventional oil and gas. If we burned all of that, we would guarantee that we would melt all the ice on the planet, and sea level would be 250 feet higher. We can't say exactly how long it would take the ice sheets to melt, but there's no way that we can do this. We know from the Earth's history. We know from the simple physics. This was a photo that I used actually for that talk that I prepared for Washington and was given in Iowa City. I was using my grandchildren to try to help explain the physics of how this works. As you put added CO2 in the atmosphere, it reduces the heat radiation to space, and therefore you have more energy coming in from the sun than going out. And that causes the ocean and the atmosphere to get warmer. But the point was, sorry, I'm losing track of what I was going to say, but the point was, the administration didn't like my talk. In fact, when I arrived in Iowa City, there was a telephone call waiting for me from the chief counsel of NASA telling me that I should not give this talk. I had actually sent a draft of it to Andy Revkin at the New York Times, so he knew, NASA knew what it was about. And they said I would be violating the Hatch Act, which prohibits government employees from getting involved in politics. But I paid my own way to Iowa City, and I was taking vacation time, so I didn't believe him, and I gave my talk anyway. Frankly, then they couldn't do anything about it. But then the next year at the AGU meeting, I gave the same talk, and it was a little better. I had more data by that time. And then there was, at the day of the AGU meeting, or the day after, there was a call from the White House, more than one call, to NASA headquarters. And then I was told that I could no longer give talks without prior approval from NASA headquarters. And if I received a request from the media for an interview, I had to tell them about it, and they might substitute alternative who was better qualified to speak to them. And after that had happened a few times, then I told the New York Times, and they were forced to change that strange policy. But there were consequences of that, because within I had been using this phrase. The first line of the NASA mission statement was to understand and protect the home planet. And I used that as a justification for doing what I was doing and speaking out about it. Well, that statement within a couple of weeks disappeared. It was removed by the administrator without asking anybody else, even though it had been developed with input from the entire NASA personnel. And in addition, they reduced the climate research and analysis budget by 30%, retroactive to the beginning of the year. So things were becoming clearer, and I was beginning to get more grandchildren, my son's first grandchild. And this is when, then Jake had a baby sister. And Jake likes to think that he can protect his baby sister. However, Jake has a severe peanut allergy. On a scale of 1 to 10, it's a 10. You can't go anyplace without an EpiPen. But that's kind of symbolic of what we're doing. We're putting young people in a situation where they're going to have to look out for themselves because we're not doing it. That's when I started saying that I didn't want my grandchildren to understand, to say that Opa understood what was happening, but he didn't try to make it clear. And so since then, I've been spending more effort on trying to make it clear. And I thought that the U.S. was somehow backward on this topic, and that other countries were have a better chance of persuading them to take policies that would lead to the phase down of fossil fuel use. Well, I found it's not different. In other countries, the fossil fuel industry, money talks in capitals around the world. It's not just Washington. There is one exception that's worth pointing out, and that's Sweden, which decided to have a high carbon tax, and they decarbonized their electricity entirely. It's about half hydropower and half nuclear power. That's fundamentally what we have to do. We have to decarbonize electricity. If we can do that, we can solve the problem. Because you can make, the reason they still have 25% of, in this, whatever the units are in the carbon intensity, is because their vehicles are still using fossil fuels. But if you have carbon-free electricity, you can make liquid fuels that are carbon-free, that may take carbon out of the atmosphere to make the fuel, and then it puts it back when you burn it. So if we could just do that, but that's not so easy, especially in countries like China and India. What's actually happening is fossil fuel emissions are accelerating. They're actually going up faster now than they were before the Kyoto Protocol. And temperatures are going up. Well, in the last decade or so, they have not gone up much, but they are going to go up this decade. We know that because the planet is out of energy balance, and we can now measure that. That excess of energy coming in over that going out can be measured because the atmosphere is very thin, so it has very small heat capacity. Most of that excess energy has to be going into the ocean. A little bit is going into melting ice and also into the continents, and we can measure the ground temperature in the continents, which shows that some heat is going in there. But it's mostly going into the ocean, and we can now measure that from these several thousand Argo floats that have been distributed around the world's ocean. They dive down to 2 kilometers, come back to the surface, and radio their measurements to a satellite. And what we find is that the heat content of the ocean is going up at a significant rate, about 3/4 of a watt per meter squared, which doesn't sound like much, but it's equivalent to 500,000 Hiroshima atomic bombs per day, every day of the year, with that much energy going into the ocean. And one of the main consequences of that, well, one thing, come back to that, but one thing that's happening, you can see each decade has been getting warmer. Now the first 3 years of the present decade, which is the chart way on the right bottom, is about the same as the prior decade, but it's going to be warmer, averaged over the full decade, just because of that extra energy that is pouring in. However, where it's warm depends upon the weather patterns and the jet stream waggling in any particular season or year. You may remember 2012, the upper right-hand corner, North America and the Midwest included, was really hot. In fact, it was the hottest year in the instrumental record. Now, by luck, last year and this year so far, the eastern 2/3 of the U.S. has been cool. In fact, the coolest place on the planet this year has been, relative to what's normal for that location, has been the eastern 2/3 of the U.S., but that's the dice. We're going to get, in general, more frequent hot and unusually hot seasons. So the situation is that we have a planetary crisis. Because of the inertia of the system, we've only experienced about half of the warming that we will get due to the gases already in the atmosphere. And the danger is that we can push the system beyond tipping points where young people inherit a situation which is out of their control. Let me mention a few of the climate impacts. Those that I am most concerned about are those that are irreversible, and that includes extermination of species and rising sea level, because it takes thousands of years to build up an ice sheet. If we allow them to melt, they won't come back on any time scale that a human would care about. And there are also impacts on climate extremes. The reason that species are threatened, we're doing lots of things to put stresses on different species as we essentially take over the planet. But if that's combined with rapid shifting of climate zones, then that's going to cause the potential extermination of many species. IPCC estimates from 25 to 50% could be committed to extinction by the end of this century if we stay on fossil fuel business as usual. I show as an example the monarch butterfly, which I had thought that was a nice way to introduce my grandchildren to nature. So we started planting milkweeds because the big stress on monarchs is the Roundup, the herbicide that farmers use to kill weeds, because it kills milkweeds, and that's the only thing that the monarch caterpillar larva can eat. And so the monarch population has been decreasing. When my wife and I were younger, we could see a dozen monarchs at the same time. Now you either see none or maybe one. But we did, and this was in 2011 when I took a photo of this broken wing female butterfly in our backyard. And because of the broken wing, I could identify as the same one who stayed around for a few weeks. She apparently decided she wasn't going to fly any further, but she produced about 25 or 30 of these larvae, which then crawled off into our privet bushes, and a couple of weeks later, here were two of them emerging from their chrysalis at the same time, one of them being a male and one of them being a female. But then we wondered how many of these would make it to Mexico. This is a remarkable insect. You know, it hibernates in this small volcanic mountainous area in Mexico, in central Mexico, and will fly all the way to Canada. But it takes 3 or 4 generations to make that annual round trip, but it somehow finds its way back to the same small region of fir trees, usually to the same tree that its great-grandparent came from. How they do it is somewhat of a mystery. But we wondered how many would make it through Texas because of the severe drought that year in Texas. I wrote an article about that broken-winged butterfly, and a Mexican scientist sent me an email and some photos that winter of the fir trees. This is a branch of the fir tree where the monarchs were accumulating. It turned out that there was 30% reduction in the number of monarchs that made it that year. And then the next year, there was that severe drought in the Midwest, and even fewer made it to Mexico the following year. That's the grandson of the Mexican scientist, and he was trying to, well, what they saw when they looked up at the top of those trees was not only butterflies, but also that the trees were under stress because of the continued drought for a few years in this region of Mexico, as the climate zones are shifting, it's putting stress on these fir trees. And so he was trying to persuade the Mexican government to plant these trees higher up the mountain where the climate would be more amenable. But then last summer, we saw only one or two monarchs. One of them was a male that landed on the butterfly bush and on the milkweeds that we had planted, but he only spent a few minutes there, and then in a couple hours he flew all around the property. And I wondered, what is he doing? You know, butterflies are different than birds. When the whooping crane almost went extinct, when I was a paper boy, I would see at the bottom of the Omaha World Herald the number of whooping cranes that had made it to Texas where they winter. It got down to only about 20 birds, but they have come back to now a few hundred. But they travel together, the male and female. Well, it's not the case in most, at least not in the eastern U.S. Monarchs have to bump into each other by chance, have to find each other. They don't travel together. So I wonder if we haven't passed a point where they're going to go extinct in the eastern U.S. because there are just too few of them. And in fact, this last year it went down to only a few percent, less than 5% of what it was a few decades ago. So if we can get milkweeds back, I think it can still recover because the western monarchs have not declined as much. Anyway, but there are lots of other species. There are more than 1 million associated with coral reefs, and we're losing more than 1% of the coral reefs every year because of the warming ocean and the ocean acidification. That's the carbon dioxide taken up by the ocean is making the ocean more acid. So those animals that have a carbonate skeleton, including coral reefs, are threatened by an increasingly acid ocean. And also we're doing other things that damage coral reefs. Now the ice sheet disintegration, the basic problem with ice sheets is the warming ocean. Because the warming ocean melts the tongues of ice that come out from the Greenland and Antarctic ice sheets into the ocean water. And once those ice shelves are gone, then the ice sheets can discharge ice to the ocean much more rapidly. And we know from the Earth's history that they're capable of causing sea level rise of the order of 5 meters in a century. I would be surprised if we stay on business as usual if we don't get sea level rise that rapidly, because the human-made forcing is much more rapid and strong than any natural forcings that occurred in the past. In fact, just a few weeks ago, there's a paper that came out in which was shown that the sea level from Antarctica going out toward the north has increased along the coastline because of the ice shelves melting. They were able to calculate that it's approaching a rate of 1,000 cubic kilometers of ice per year, which is enough to make the ocean water fresher around the edges of Antarctica. And because it's less dense water, the sea level is then higher, closer to the coastline. And you can measure that from a satellite. We're close. I think we're close to a tipping point where those ice sheets are going to be. We won't be able to stop the process from continuing to a large level. We also see the area on Greenland with summer melt is increasing, even though it fluctuates with the weather from one year to another. And that meltwater will go to a low point on the ice sheet, burrow a hole in the ice sheet, go to the base and lubricate the base of the ice sheet. And that also helps speed up the discharge of icebergs, although it's the warming ocean that's the more serious issue, I think. And we can now measure the mass of these ice sheets, Greenland and Antarctica, because of the gravity satellite, which measures the gravitational field so accurately that we can see the changes in the mass, and they are losing mass at an increasing rate. Sea level is only going up at a rate of a little more than a foot per century, but that's a lot faster than it was last century, and I think as I said, I think there's a danger we're going to pass a tipping point, and it's going to become a lot faster. Now, with regard to, and the paleoclimate tells us we had better not let global temperature get 2 degrees Celsius warmer than pre-industrial or more, because the last time it was that warm. And what we've learned, even since we wrote our last paper last December in PLOS ONE, we thought that the Eemian was 2 degrees Celsius warmer than the Holocene, than the pre-industrial Holocene. It turns out that the assumption that the warmest time in the Eemian occurred at the same time on different parts of the planet is not true, and so the Eemian was probably only between 1 and 1.5 degrees warmer than pre-industrial, and we've already warmed it 0.8 of a degree, so we're getting close to a very dangerous level. Now, with the final thing, the thing that people are beginning to notice, I think, is a change in the climate extremes. And that, for one thing, is related to this bell curve that describes the natural distribution of seasonal mean temperature about the average. The one on the left being the bell curve that existed in the middle of last century, 1951 to 1980. But what global warming does is cause that bell curve to shift to the right. And so what was a very unusually hot anomaly, 2 or 3 standard deviations, occurred very infrequently 50 years ago. But now it can occur of the order of more than 3 standard deviations about 10% of the time. And that's what we had in 2012 in the Midwest, and 2011 in Texas and Oklahoma. And when you do get those high temperatures that go with high pressure system, the fires that are caused burn hotter and they're more damaging. We're actually getting that in California and West Coast this year. And we see an increase, which is partly due to other factors like poor forestry management. But as I mentioned earlier, you also expect to get more extreme rainfall and floods, and there is statistically clear increases in extreme rainfall and floods. Those storms that are driven by latent heat, the energy in water vapor, that includes thunderstorms, tornadoes, and tropical storms, all have the potential to be stronger as the atmosphere holds more water vapor, because that's the fuel. And there's a marginal relation of warming to this Sandy, where the storm was able to maintain hurricane strength all the way up to New York City because the waters along the East Coast were about 3 degrees warmer than normal. And that then connected with the frontal storm and moved inland all the way, causing damage all the way to Lake Erie, and a lot of damage in the East Coast region. And it did get, one of the problems is, despite the importance of this issue, you can't get the politicians to pay any attention to it. In the campaigns, it almost doesn't come up. I think that is our poor old milk cow up on the upper right-hand corner. Yeah, so what I mentioned earlier was we can't burn all these fossil fuels. We need to phase out the coal and leave the unconventional fossil fuels in the ground. But that's not what's happening. Instead, we have governments that allow and encourage fossil fuel industry to go after everything that can be found. Tar sands, tar shale, fracking to get gas, deep ocean drilling, drilling on public lands. It doesn't make sense. And it is a case of intergenerational injustice because we're creating a situation where the consequences will be felt by young people. And we can only pretend. Our parents didn't know that they were causing a problem, but we can only pretend that we don't know. And it's kind of strange because you wouldn't think, given the history of the United States or the attitudes of indigenous people toward responsibilities to future generations, and religious attitudes which say we should preserve creation. But all those things are ignored by governments which fail to provide leadership. On a complex issue like this, you can hardly expect the individual citizens to figure it out. You know, we have a National Academy of Science, which Abraham Lincoln established to advise the government on complex scientific and technical issues, and they say the right words, but the governments pay little serious attention to it. And the problem is, unless we address it, we can't solve the matter. But the fundamental problem is that fossil fuels appear to be the cheapest energy to the user. And that's because they are partly subsidized, they're indirect subsidies like protection of the supply lines, which are enormous cost. But if you would only add the human health cost, the air pollution cost is enormous. If your child gets asthma, you have to pay the bill. The fossil fuel company doesn't pay it. And the climate impacts, if there are climate effects, those are paid by the victims, and by the taxpayer if the government helps out, not by the fossil fuel companies. So the solution is to add a price to fossil fuels, to collect a fee from the fossil fuel companies. And it's very easy to do because the number of sources is small, domestic mines and the ports of entry. You just collect the money at the first sale, and that will completely cover all of the carbon sources, unlike most of the cap approaches. But that money should be given to the public, an equal amount to every legal resident. That way, the person who does better than average in limiting their fossil fuel use will make money, and it will be a huge incentive for them to pay attention to their carbon footprint. And it will be a huge incentive to entrepreneurs to develop clean energies and energy efficiency. And unless the money is going to the public will never allow the fee to increase, because if it's not given to the public, it's a tax. It will increase the cost of energy. And they don't want to see the price of fuel at the pump to go up unless the money is going to them. And this is a conservative approach because it lets the market decide what are the winning technologies and how much energy efficiency can provide. And it does not enlarge the government. It stimulates the economy. In fact, now there's been a study commissioned by the Citizens Climate Lobby, by the Regional Economic Modeling Incorporated, which is a well-respected, nonpartisan economic group. And they found that if you put a $10 a ton tax or fee on carbon collected from fossil fuel companies, going up $10 a ton each year, at the end of 10 years, it will reduce U.S. emissions 33% and 52% after 20 years. At the same time, it will create 2.1 million jobs in 10 years and about 3 million in 20 years. And actually it'll increase the gross domestic product. So the claim that it's too expensive to deal with climate change is baloney, to put it mildly. It actually, it makes sense. Every economist would agree that if you make the prices honest, the economy is more efficient. You don't want to subsidize things. Make the fossil fuels pay their honest cost to society. Furthermore, this is the only approach that can work internationally. You can't put a cap on every 180 individual countries. That's what they're trying to do with the Kyoto Protocol, and of course they didn't even try. They only tried with Europe and the developed world, and then what happened was countries that agreed they were going to have a cap, some of them just ignored it. There's no way to enforce it. And what would be the cap on India? I mean, now the emissions are not so much from the developed world, the developing world. India is not going to accept a cap that's effective. Their emissions are 1/20th, 5% of those in the United States per capita. And they want to we used fossil fuels to get wealthy. They want to do the same. So but they would actually be better off with a system that pushed them to modernize the energy systems. And all we need is, say, the US and China to agree to have a carbon fee, and then they would, and it could even just be the US for that matter. We have enough economic clout. And then the countries that do agree to have a carbon fee would say we're going to have a border duty on products from countries that do not have an equivalent carbon fee, and that would be a huge incentive for the other countries to have an equivalent fee, because then they can collect the money themselves rather than us collect it at the borders. So that's, but yet we don't, that's what we need to do, and we need to educate our government, and that's why there is this one organization, Citizens Climate Lobby, which is trying to do that. I think I've already said this, and this shows the actual contributions. The lower bar graph shows the contributions to the total amount of carbon in the atmosphere, and you can see China and India are a very small fraction of the US, Germany and United Kingdom contributions on a per capita basis. But you know, this is a tall order. There's a lot of potential in energy efficiency and clean energies, but right now most of our energy is coming from fossil fuels. And although you hear a lot about renewables becoming a bigger source of energy, it's still only non-hydro renewables are about 3% of our energy in the US. And globally, the same thing is true. Fossil fuels are providing more than 85% of the energy, and non-hydro renewables about 3%. So we do need to have R&D on clean energies, but mostly that's going to be spurred by the rising carbon fee. The government is just too darn slow. I've worked for the government for decades, and it's not the place where you're going to get things to happen fast. And it's not the place you get things done as inexpensively as possible. A government employee, you can't fire a government employee, so it just is not. So we're even things as complex as a new nuclear technology. Now, Bill Gates is funding one himself. We've got a lot of very wealthy people who can afford to even do that kind of R&D. So we really need to stimulate. And we still have, in the United States, the most potential of any country for innovations. And we have an educational system with some of the best universities in the world. We can do this, but you have to have the incentive. You know, I've met with some of the CEOs of the biggest utilities in the country, and they say they're not the enemy, you know, but they say we can help solve the problem, but the government has to give the right incentive, because their main duty is to make money for their stockholders. So you've got to, but they say if you put a rising fee on carbon, we'll change our investments and move to clean energies. But you have to have that incentive to drive it. So that was that. And as I showed earlier, the emissions, however, are going up at a rate of about 3% a year. So although we have been funding renewable energies with incentives for a few decades, their 3% that has grown over those decades is now 1 year's growth of the global emissions. So we need all the players in this, not just renewables. We need all the no carbon energies, and that. How do I start this thing? If I want to show just 1.5 minutes of this.
Davis Band. Ralph Nader.
If we stop nuclear power, or shall we say, when we stop nuclear power, we will usher in throughout the United States and the world a new energy alternative. The sun which Exxon doesn't like because it's free, it's abundant, it can bypass Exxon. Stopping atomic energy is practicing patriotism. Stopping atomic energy is fighting cancer. Stopping atomic energy is fighting inflation. Stopping atomic energy is saving this country.
I want the energy that we have now. We have to have either oil or coal or whatever, but certainly not nuclear. Even wood if need be. I have a coal stove at home if you want to know.
Flash!
Yes.
Turn it on.
I don't use it now, but if I have to, I will. And I live 1 block from the mayor, and I have a coal stove. Put that in your house and smoke it.
We'd like to sing the Johanna Hall song for you to become sort of the song of our movement.
Just give me the warm power of the sun. Give me the steady flow of the waterfall. Give me the spirit of living things as they return to clay. Just give me the restless power of the wind. Give me the comforting glow of the wood fire. But please take all your atomic poison power away.
Yeah, it's pretty hard to. It's pretty effective politically to be anti-nuclear. They, in that little clip, they mentioned not only the preference for coal, but also a preference for the warm glow of a wood fire. There, in the past year or two, there's been this really, oh, that's not what I wanted. I don't seem to have it. Well, there's been a study by, published by about 20 of the leading world health professionals on the consequences of air pollution. And they determined that outdoor air pollution is killing 3.7 million people per year. You know, more than 1 million in China, and it's equally bad in India and some other Southeast Asian countries. In the United States, it's in the tens of thousands. That's mostly fossil fuel pollution. Indoor air pollution comes from burning coal, wood, field residue, and in some cases cow dung. The number of people dying from that was estimated at 4.3 million per year. So it's a little, then we can compare that with the effects of the nuclear radiation that has been released in nuclear accidents. In the 3 Mile Island case, if you believe the so-called linear no-threshold hypothesis that even the smallest amount of radiation can kill someone just at a lower level than high levels, then you could argue that 3 Mile Island might kill 1 to 2 people within the several decades, including decades in the future, of Pennsylvania residents who were exposed to radiation. Those same residents will have 40,000 people die from cancer from other causes. So the number is very small, and it's also highly debatable. There's as much evidence that suggests that low-level radiation is actually beneficial to health. Life developed on this planet bathed in low-level radiation, and it's actually decreased over time as the Earth has gotten older. But there are good biological theories for how life usually takes advantage of its environment. Those things that succeed are the ones that were able to take advantage of it. But in any case, it simply doesn't make sense. There's something irrational going on here. And there's a good book by Spencer Weir, a science historian, it's titled The Rise of Nuclear Fear, which helps explain the psychology of this. But it's distressing that politicians take advantage of this psychology and to get more votes. So Bill Clinton, in his first State of the Union message, declared, "We are eliminating programs that are not needed, such as nuclear power research and development," right at the time when Argonne National Laboratory, our leading nuclear laboratory, was ready to make a large-scale nuclear, a fourth-generation reactor, which allows the neutrons to move faster so that it can burn essentially all the fuel. The current generation of the 100 nuclear reactors in the United States are slow reactors that burn only 0.6% of the energy in the fuel, leaving the other 99% as a waste product with a half-life of more than 10,000 years. While with a fast reactor, you'll have a smaller waste pile with a half-life measured in decades instead of millennia. And these kind of reactors are able to burn nuclear waste and solve the nuclear waste problem, as well as burning excess weapons material. And we have technology now such that a nuclear reactor can shut down if there's an anomaly like an earthquake, so you can avoid the kind of problem that Fukushima had. And they do not, you can have a design that does not require power to keep the reactor cool in case of a shutdown. Furthermore, with this kind of reactor in the reactor mix, if you have some fast reactors in your nuclear power mix, then we wouldn't need to mine uranium. We actually have enough fuel in nuclear waste and weapons material for about 1,000 years, but we can sieve nuclear fuel from the ocean, and enough at a rate that it could last billions of years, because it's leached from the ocean's floor into the ocean at a rate that could supply all of our energy. So we should not be closing the door on the one alternative that we have for baseload electric power, the one alternative to fossil fuels. We should at least have continued the research and development on that. And we should not think that nuclear power is going to disappear from the planet if the U.S. decides to close its nuclear reactors. There are many other countries that have nuclear technology, and Russia is eager to sell their technology to the world, including the fourth generation fast reactors. They have such a technology. But I think we will have a much more dangerous world if we leave. When Eisenhower proposed atoms for peace, he proposed that there should be an international organization to oversee this, and the U.S., with the U.S. having the lead role in that. Well, it has worked out that way, but if we bail out, our ability to influence international control of nuclear material will be greatly diminished. So I think that's a huge mistake. And there's also a moral issue here, because the United States is responsible for more than a quarter of the excess of the human-made CO2 in the atmosphere, even though our population is like 5% or something of that order. What we did, now the science tells us we've used most of the carbon budget. We've got to phase out fossil fuels rapidly. So in other words, we burned our share of the carbon budget, and then we started burning China's share and India's share, and we've burned a large fraction of their share. Yet we will not help them with the technology such that they can have an alternative. And by shutting down R&D on the one, China and India are not going to be able to power their energy requirements with just the sun. I guess I didn't have a chart I wanted, but the point was that these other countries, you know, we can only solve this, to look at this problem in a larger perspective. We have to solve the global poverty problem and the global population problem. We solved the population problem in half of the world. Half of the world became wealthy. And that half of the world, the fertility rate of women has declined to the replacement level or below. But the population is still surging in the other half of the world, which is in the poverty half of the world. So China is controlled its population just by fiat, and it has lifted a large fraction of its population out of poverty, and it's continuing in that direction. India wants to go the same direction, and both of these countries have a lot of coal. They're determined to raise their standard of living. And we have no right to tell them that they can't do that. So if we want them to not use coal, we had better help them find another way. And instead, we withhold our knowledge of the technologies. And we're cheating our young people by doing that, because not only are we pushing the planet down a bad path, we're also making their economic futures dimmer. We have the potential to be the most advanced nation in the world. We still have the potential to innovate, and we're just not taking advantage of that. If we instead allow fossil fuel industry to keep us on this path where we're addicted to fossil fuels and try to become a bigger petrostate, which is now not only the Republicans but the Democrats are also clapping themselves on the back that we found ways to extract more fossil fuels from the ground. That, unfortunately, is not in long-term future or a way to ensure the optimum economic development for our country, or for a situation where our young people can look forward to lives as good or better than what we older people have been able to experience. I'm actually optimistic. And the reason I've become optimistic is because there's this one organization, Citizens Climate Lobby, which is growing rapidly, and it's becoming international. It's in several countries now, although mostly in the United States. And they are advocating a carbon fee with 100% dividend distribution to the public. And some politicians are actually hearing this. So people like Barbara Boxer and Bernie Sanders, for example, introduced a bill. They're Democrats. They introduced a bill for a fee and dividend, but they only want to give 60% of the money to the public. They want the other 40%. And they say that they will use it to reduce the national debt. Well, that's the same as saying you're going to throw it in the government's pot, which allows the government to be bigger. Conservatives will never agree to that, and it won't work. It won't be as effective. If you don't give the money to the public, then these calculations of how the economy will expand and the jobs will grow is different. A tax depresses the economy. Throwing money into the government's pot depresses the economy. So we really, and the nice thing about Citizens Climate Lobby is they don't make compromises with politicians who say that. They say, no, you need to do it. You need to do it this way. And they're very polite. They keep coming back. What they do is write letters to the editor and op-eds and visit Congress people. And they're trying to make our democracy work. It's not worked as well as it should because of the role of money, but it can still work, but it takes some effort. And I think we really need more young people in this effort. We really need to somehow, and it's actually a very educational thing to try to write letters and to try to visit Congress people. And it would be more effective if some young people were visiting these Congress people, senators and representatives, and letting them know that they're concerned about their future and they would like to see an honest price on fossil fuels, and we could solve the problem. I think that's the end of my charts. But here's the contact information for Citizens Climate Lobby. So I'm happy to take questions and have discussion.
So as Dr. Hansen said, we have time for some questions. We have some people going around with microphones. I will ask you to very politely please refrain from lengthy comments and instead, please take most of your time with a question.
I have a question regarding methane hydrates. If I read one of your papers, and assuming I understood it properly, you were concerned about methane hydrates, that might be a very important tipping point if they start thawing from the deep ocean, from the oceans. If you could just give an update on that, please. Thank you.
Yeah, if we allow the ocean to continue to get warmer, it will eventually lead to release of more methane hydrates. There's essentially frozen methane in the continental shelves. It's methane molecules in a cage of water molecules. And there's a huge amount of it. there's enough, and you know, the U.S. government and Japanese government are actually working on drilling into that, doing the R&D to try to develop that as a source of methane, of natural gas. And you see these stories in the newspaper about, well, methane hydrates are starting to bubble out of the ocean. Well, but we don't know. The methane hydrates have probably been bubbling, you know, there's probably a natural amount that's coming out. I might even have a slide on this. That's too bad. This is not the slides I thought I had. Oh well. The thing is, I was going to show is that methane, the growth rate of methane really peaked about 25 years ago, and then went down, and methane stopped increasing, and now it started to go up a bit, and there are lots of stories about different ways that contribution to methane. A lot of it, actually, there's a European satellite that measured the amount of methane using a methane absorption band, and which could show where the sources are over the United States. And it turns out that the biggest source over the United States is in New Mexico, Arizona, where an area of coal mines. There's a lot of methane in coal mines, and we're releasing that in our coal mining. There are other methane sources, landfills and feedlots. Methane has about a 10-year lifetime. If we would close down some of those sources, we could actually get the amount of methane in the atmosphere to decrease. And we're going to need to do that in order to restore the planet's energy balance. The first order thing that we have to do to stabilize climate is to get rid of that energy imbalance. As long as there's more energy coming in than going out, then the planet's going to keep getting warmer on decadal timescales. If nothing else changes, we would need to reduce CO2 from its present amount to 350 ppm to restore the energy balance. That's going to be very difficult. So we could use some help from methane. If we could reduce these methane sources, then, and if we stabilize the temperature and the ocean stops getting warmer, then probably those methane hydrates are not going to be a big problem. But if we stay on this course, fossil fuel use continuing to go and the curve hasn't slowed down yet, then those methane hydrates are a real threat. And that's what we mean by tipping points. And that's why we may leave young people a situation where those tipping points, if the ocean gets warm enough, then they won't be able to stop it. It's very difficult to cool down the interior of the ocean if you've once allowed it to get too warm. So it's not yet a big source, but it potentially could be.
Jim, I'd like you to think back 50 years ago, minus 1 month, when you defended your master's thesis, which in a nutshell was a time-dependent planetary atmosphere problem where the planet was the Earth. Then you went off and worked on other planets. Then you came back to that problem. I was wondering what the connection was.
My master's degree was in 1963, the volcano in the Indonesia, Mount Agung, exploded and put a lot of sulfuric acid in the stratosphere. My astronomy professor suggested that we observe the eclipse of the moon that year. And with John Zink, who was a graduate student at that time and much more capable with operating the telescope, we went out on the hill where, in the cornfield where a little telescope was, and observed the eclipse of the moon. And we saw that the moon actually disappeared. Normally during an eclipse of the moon, you can see the moon. It's kind of reddish. But this time, the moon just totally disappeared. There was just a black region. You could not see any stars because it was blocking the stars behind the moon's location, but you couldn't see the moon. And the reason was that the reason that the moon can be seen during an eclipse is that sunlight comes through the Earth's atmosphere. It gets filtered, it gets scattered by the upper atmosphere, and some sunlight gets into the shadow. So the shadow is not totally black. Well, in this case, there was so much sulfuric acid in the Earth's stratosphere that the negligible amount of light was getting through. And I wrote a paper with that professor and John Zink, deriving an estimate of how much sulfuric acid there was in the stratosphere. And then later, when I got to NASA, I used that as to estimate what would be the effect. So that sulfuric acid in the stratosphere reflects sunlight, and therefore you get less sunlight absorbed by the surface of the Earth. So it's a cooling effect. It cools the planet. And we calculated with our climate model, the one that we had built that I mentioned in my talk, and we calculated that the Earth should have cooled off by a couple of degrees Celsius, a couple tenths of a degree Celsius, and we knew that it had. Then we also used that. So that's a little. We already knew the answer before we did the calculations, but they were consistent in any case. But then when another volcano went off of comparable size, that was Mount Pinatubo in 1981, then we made the prediction before the answer, and we predicted it would cool off by a few tenths of a degree, the Earth on average, and it did. Now, I assume that's what you're referring to. That was my master's thesis. But the relevance of this, by the way, is the question that you might want to ask is, well, gee, if you can cool off the Earth that way, why don't you do that? And there are, in fact, propositions to do that. It's called geoengineering. If you want to restore the planet's energy balance, if you want to stop the ocean from getting warmer, you need to restore the energy balance. And you can do that by reducing greenhouse gases. That's what we would like to do. Or you can increase the reflection of sunlight. Well, that would not solve all the problems because the ocean would still keep getting more acid if the CO2 is not decreased. But it could restore the planet's energy balance. And so you can try to cover up this one pollutant, CO2, with another pollutant, sulfuric acid, and hope that restoring the planet's energy balance will be a positive, will be helpful. That may sound like Dr. Strangelove, but in fact, young people are going to be faced with questions like that. We're going to realize that that it's very difficult to solve this problem because it's very hard to stop. You see, the governments are not really making a serious effort to rein in the fossil fuels. So you're going to young people are going to have to figure this out, because us old people won't be around in a few decades when you probably will have to be doing geoengineering. Now, what you would like to do is something that would actually suck the CO2 out of the atmosphere. So this summer, my oldest grandchild, Sophie, and I started some experiments. We got a ton of biochar, and we're using that around some of the trees on my farm, working it into the soil, and the hope is that the biochar will both increase the fertility of and make the trees healthier, but also store carbon. And that's one way, if you know that you can get some of the carbon, because that biochar is obtained by burning some refuse, some vegetation refuse or whatever. So when that vegetation grew, it took CO2 out of the atmosphere. Then you make this charcoal, and then in effect, you put that in the soil, and it'll stay there for hundreds of years. It's very stable. So that's one way that's a soft geoengineering. And with some colleagues, we've also submitted a paper on trying to speed up the weathering process. So that's also a way of sucking CO2 out of the atmosphere, depositing it as carbonates on the ocean floor. So those are soft geoengineering things, but they all are going to cost money. So we're kind of, even if you can get them to work, which is very hard to get them to work at the speed that will be necessary. Could just imagine, for example, just the Keystone XL pipeline carrying, I think, 830,000 barrels per day. You know, then you've got and then carbon then ends up in the atmosphere. We've got to figure out how to get that back. So my poor little farm getting a ton last summer, that's a pretty small contribution. And yet this carbon fee, $10 a ton, going up $10 a ton each year, at the end of 10 years is reducing emissions 33%. That's equal to 12 Keystone XL pipelines. It's a much easier way to solve the problem, and it doesn't cost a cent. It actually improves the economy. It just is absolutely crazy what we're doing and what we're not doing. And yet we can't seem to communicate this to the people that would matter. And it's not surprising that it's hard to communicate, because the wealth of the world is substantially fossil fuel wealth. And the rationale, the logic that they use, which you hear on television every single day, is that, look at what we're doing. This is making us energy independent. This fracking and stuff is all very good. Well, yeah, so it's very hard to get the kind of policy that would be needed when you're fighting against that kind of advertisements. And gas, frankly, is useful as a transition fuel, but we're not treating it as a transition fuel. We're treating it as though, oh, we need more and more of this. Yeah, long answer for.
Dr. Hansen, Okay. Two quick questions. What is the likely impact of unmitigated global warming on the Atlantic Gulf Stream? And the second question is, what's the potential for thorium as a way of promoting clean nuclear energy?
Those are two very good questions. The first question was about what's the effect on the Gulf Stream. Poor old Wally Broker, who proposed that the increasing, he recognized that in the paleoclimate record, this thermohaline circulation had essentially got shut down by the addition of fresh water to the North Atlantic Ocean from melting of ice sheets. And he suggested that we could do the same thing by continuing on our path. He got beat heavily about the head and shoulders, and the scientific community said that's not going to happen because our models don't show it, or they show only maybe a little slowdown of that deep water formation. The global ocean circulation has this deep water forms in the North Atlantic Ocean. The salty water from the Mediterranean goes to the North Atlantic, and then it gets very cold, and because it's salty and cold, it sinks to the bottom or deeply into the ocean and sort of drives or contributes to this global ocean circulation. Well, it so happens that we have a paper nearly finished which says that Wally is actually right. And the reason is that their model, the IPCC models don't include Greenland melting at a significant rate. And I think they're wrong that, in fact, if we continue on this business as usual path, we're going to get rapid fresh water from the Greenland ice sheet. And in fact, in our model, it shuts down. The North Atlantic cools by several degrees Celsius, and all hell breaks loose, because the temperature gradient between low latitudes and high latitudes, because this is different than the paleoclimate case, because we're continuing to pump CO2 into the atmosphere, which makes the low latitudes warmer, continue to get warmer, while we cool off the North Atlantic. So I think that is a potential future, and hopefully we're smart enough not to go down that path, but it requires that we phase down fossil fuel emissions. And your second question was, about thorium. Yeah, in fact, that's an example of, the reason we didn't develop thorium nuclear reactors was the military preferred uranium because they wanted the plutonium for weapons. Thorium, it would have been a preferred alternative. It's easier. We can if we pay attention to the R&D, we can make the uranium-based nuclear reactors safer and more resistant to weapons, potential weapons proliferation. But it would be easier with thorium. And also, that's what India wants to. They've got an enormous amount of thorium. We should have helped them, but we withheld our capabilities, and that, as I say, I think that's immoral, because we're putting them in a position that now they're pumping out air pollution, which is killing people like crazy, but is also bad for the planet because it's putting all this CO2 in the atmosphere. Yeah, that's R&D, which we didn't do, and we knew that we should do it. It's inexcusable, because Bill Clinton's vice president was Al Gore. He knew about the climate problem.
Dr. Hansen, firstly, just wanted to say thank you for continuing your I'm over here. Hello? To your left.
Where? Oh, okay.
Sorry.
There you are.
Thank you for continuing your public advocacy. I'm sure we'd all agree we don't want you to retreat back to your lab and into reclusiveness. I want to ask about costings. All right, the renewables industry is relatively small, 3% you quoted, but it is growing very fast, and the cost profile of certainly of solar PV, concentrated solar, it's very well understood. It's on the shelf technology, and we're using it and building it up fast. In the nuclear case, certainly earlier generation nukes, the costs were underestimated, particularly in leaving out things like decommissioning and so on. So, I mean, what confidence have you got that the future generations of nuclear power, assuming it can be brought in fast enough, which is another whole point, but what confidence have you got in the costing profile? Because it seems to me that the solar PV is ready to, well, it is growing exponentially, whereas the nuke is essentially flatlining, certainly in this country. Where do you see the economics, the costs going?
Yeah, I think what we need is to let these renewables like solar compete with nuclear. But we need to have a playing field which is level, and the main thing that will drive that is this rising carbon fee. The history is that the nuclear is far faster to be put in place. So, for example, when France decided they were going to do nuclear, they decided on a design, and then in 10 years they had gone from 8% electricity to 70-some%. And it was not much different in Sweden. They made a decision, and you can do it rapidly. Now, in the case of, I hope that that your optimism about solar is right, and I've tried to do my part. I covered my barn with solar panels, and we generate twice as much energy as we use. And for me individually, it made economic sense. It cost $75,000, but Pennsylvania gave me $17,000, and the federal government gave me $23,000. And they passed a law that said the utility had to buy my excess energy, whether they wanted it or not. And so I get paid for that. And there's also a so-called renewable energy credit that some companies are forced to have, and I generate those and can sell them. The market for those actually collapsed, and I haven't bothered to look into what I will get from those. But that made it, for me, economically okay. I will get paid back within 20 years. But that kind of system works only if the number of people is a small percentage. It's like a Ponzi scheme. You can't, who's paying for that $17,000 from Pennsylvania? Taxpayers. Who's paying for the $23,000? United States taxpayers. And who's paying for the fact that the utility, when it has to buy my electricity, it still wants to make money, so its rates are, the costs are passed on to the other ratepayers. So but that's okay. This whole thing was an idea. We know that, and the government knew that what it was doing, that it's financing this thing because it wants to get it started, and it wants to, and so it may well work, but to some degree, but they haven't yet solved the fact that these renewables are intermittent. There's going to be some added cost if you're going to have to store the energy. So again, they say, well, we will require the utilities to have some percent of their energy from renewables, but they know they can't make it 100% unless they have energy storage, which we don't have economic energy storage. So that exponential growth is because of the economic incentive that is there. And so investors, including the big wealthy ones, are saying, well, gee, if the government is going to do that, then we'll take advantage of it. But I think that there's a role, for renewables, including solar. Clearly, there are, you have these individual panels out there where you don't want to have the grid going out there. Whether it will ever be providing grid continuous power is somewhat dubious. You can compare. So California is trying very hard, and they are requiring the utilities to have a large amount of renewable energy. So a solar thermal plant opened recently on the Nevada-California border. It cost $2.2 billion, and it produces X amount of electricity, which is 1/12 the amount of an AP1000 Westinghouse AP1000 light water reactor. China is now building, almost finished, 2 of these AP1000s at a price of $3.5 billion each, and it's making 12 times more energy than the solar, and it's continuous energy, it's not intermittent. So but if you tried to make the AP1000 in the US, it'll take you, and it took them 5.5 years. But in the US, it'll probably take you 10 or 15 years, and it'll cost you a lot more money, because to tell you the truth, a lot of the, under a number of Democratic administrations, and by the way, I'm equally critical of Republicans and Democrats, but under the Democrats, they've been anti-nuclear, and sometimes appoint heads of NRC who actually are anti-nuclear, which is crazy. If you've got a nuclear agency, you don't want someone who's against it heading it. But that recent head, I don't know if I'm pronouncing his name right, Jacos or something like that, took him 5 months to have a meeting to put the final stamp of approval on a finished nuclear power plant, which just makes the nuclear power more expensive. Not as fast as Obama, he caught the fly. But yeah, it remains to be seen. We should, if we had taken advantage of our technological capabilities, we would be making modular nuclear reactors where you can make it in a factory and then ship it to the site, and if at a scale that would be smaller than our largest reactors, but if you want a large power source, then you get 8 of them or something and hook them all together. We could find ways to make nuclear less expensive, but if you're not doing the R&D, and if you're not building them, then the price is going to stay high. But we'll let them compete. And China wants to buy 100 of these AP1000s, and they will. And when they do make a lot of them, they're going to find ways. They want to get the building time down to 36 months, and they will probably become even much cheaper than the ones that they're just finishing. So it remains to be seen.
Dr. Hansen, several times this evening.
Excuse me, we have time for one last question.
Okay.
Please, question.
This is it? Okay. You've several times this evening referred to the efficacy of the carbon fee and dividend program as outlined by Citizens Climate Lobby. And I wanted to say that we have a Citizens Climate Lobby chapter here in Iowa City, and we would love to have many, many of you be part of that And I suggest what you do is to either go to citizensclimatelobby.org or Iowa City Climate Advocates website and learn all about it. My question is, could you tell us a little bit about what you're doing with Our Children's Trust? Because that's a unique way of trying to get into this whole thing, I think.
Yeah, well, Thomas Jefferson and James Madison exchanged some letters about the responsibility to future generations. And Jefferson was a farmer and was concerned about the fertility of the soil, and argued that we should be required to leave the soil in equally good condition for the next generation. There is a long history toward the concept that we're holding in trust for future generation the bounty of our planet. And Mary Wood at the University of Oregon has developed she's a lawyer, a legal scholar, has developed the concept of this atmospheric trust, and then as using that theory, there's been an organization called Our Children's Trust, headed by Julia Olson, which is filing legal actions against the federal government and state governments to protect the rights of young people by asking the courts to require the government to at least give its plan. How is it going to phase down emissions at a rate that would allow climate to be stabilized? Now, there's some cases in courts now with some success and some failure, and it's unclear as to what the ultimate outcome will be. My own opinion, and if I can get the funding, I want to add a legal person to my group, because I want to file a suit against the federal government using the most fundamental things in our Constitution, which are equal rights, equal protection of the laws, due process. The Constitution says people cannot be deprived, that all people get equal protection of the laws and cannot be deprived of property without due process of law. And that includes young people. And partly I'm saying this in reaction to some of the response to some of the cases that Our Children's Trust has filed, where the D.C. District Court argued that Our Children's Trust did not show a constitutional basis for their claim. While I think if we file a case based on equal rights, the same principles that civil rights, the way that they won some cases, and courts required the government to desegregate schools or give a plan. The courts can't do this themselves, but they can require the executive branch to at least provide a plan for how it's going to assure equal rights.
For any of you who are interested in this lecture or sharing it for others, it will be posted on the Public Policy Center website in about 2 to 3 weeks, ppc.uiowa.edu. Included in that will be the debate last night and all of the symposium content from today as well as today's lecture. Again, thank you very much for coming, and we appreciate your interest.